dinuclear compound. In case of ruthenium, this dinuclear unit has 3 ampere electrons between ruthenium bonding, and we can use this unit to make some magnetic compound. So this unit has therapeutic splitting, so magnetic behavior like showed like behavior, and this was analyzed by Professor Telsa for the first time. And this spin, the effect of this spin, we can see on the NMR spectra as a large upward shift of carbon atoms. And this unit, we can make a chain compound by using this unit like this. If we add long alkyl groups for this unit, we can expect some hydrophobic property and liquid crystalline properties. So my student synthesized many this type of compound. And he found anti-magnetic interaction between this unit becomes stronger with longer alkyl chain. So we call this one molecular personal effects on magnetic properties, because many years ago, molecular personal effect was proposed by Professor Inoguchi for the organic conductor materials. So these compounds show some liquid crystalline properties like this. For making chain compounds, we introduced this kind of NN didentate ligand to produce chain molecule. And next we used organocyanoligand to connect this unit. And mostly we obtained very weak anti-magnetic interaction between these spins. So if we use ruthenium-22 starting material, we could obtain ruthenium-23 and radical and ruthenium-23 spin like this. We could obtain chain compound. And we observed paramagnetic, we could obtain paramagnetic species. But we could not get single crystal for this system. As for ruthenium-22 calcium, Professor Miyasaka's group reported many interesting chain compounds. So we moved to use inorganic cyan groups as linker groups. So dicyanide argentate, we obtained some adapt, but we could not get chain compound for these systems. Magnetic property is like this, with very weak anti-parametric interactions. And we could not obtain a single crystal for this system. So next we use tetracyanide metallate ion, and first we use nitrate to make mixed metal species, and we could see the presence of nickel linkers with retaining species in the diffuse reflectance spectra. And this system we could obtain again very small weak interaction, and we could not get a single crystal for this system, and we suppose our compound has have this kind of structure, and we can observe very weak anti-paramagnetic interaction between retaining spins. But for this system, Miller group reported synchrotron powder attraction data and found this kind of assembly structure. So when I saw this report, I was disappointed to we could not obtain single crystal for our system. But in other point, this encouraged for us to continue our study. And we used the palladium system by using tetracyanide paladate. We could obtain some assembled compound. And we could get the crystal structure of one compound, this series. And the nuclear units are connected by tetracyanide nickel to form assembly structure. And we can see some two-dimensional structure. And we measured absorption property for nitrogen for this system. But we got the type 2 absorption. So because of the very small void space here. Magnetic interaction is very weak anti-parametric behavior we observed. So next we used platinate linkers. By using tetracyanide platinate, we obtained some assembled compound. Magnetic behavior very weak anti-magnetic types we obtained. And for this one, very small crystal we obtained. So Dr. Mitsuhashi measured this sample at the spring rate, and he found this structure. And this one has two-dimensional structure like this. And this one is acetate, so we can expect some void here. And absorption behavior was like this. So type 1 plus type 2 or something. So anyway, this compound adsorb nitrogen gas. So nickel paradate platinate. So then we need to orate 3 ion. We connect retaining units, and we can see the resistance of orate here, and we obtain the single crystal, and we found chain structure here. In this case, acetate case, we obtain this one is trans binding for retaining unit. For propionate, we obtained similar structure, but in this case, this one bind in cis position to this retaining unit. And we add more methyl group, and we obtain this like this. And by using fibrate, we obtain trans connecting chain compound here. And this one again shows very weak anti-pyramid interaction between the retaining spins, like this. And structure shows almost no void here, and the adsorption properties like this, just type 2 adsorption. So, orate, we could obtain 2 kinds of species in chain molecules. So, to make magnetic material with 3-dimensional linker are much better. So, for example, octacyanide metallate, using this unit, we obtained ruthenium-2 and cobalt species many years ago. And this one has ferrimagnetic interaction, and Miller's group also more studied more detail, in more detail, and what beautiful result. In our case, we obtained crystal structure for this compound, and like this. So this kind of 2-dimensional units are arranged in 2-dimensional. And by using 8-coordinate metal unit, octacyanide tungstate, this case. By using fibrate, this crystal contains 1 water molecule, and water molecule here. So tungstate linker bind 3 retaining unit, and forms a similar 28-membered ring-shaped rings, likely similar to the retaining ion systems. And 2-dimensional sheet loosely connected by this routine unit. This one has paramagnetic behavior like this. And when we put tetraphenyl phosphonium ion to this system, we could obtain similar compound, but in this case, we can see the chain structure and this counter cation. This one shows a similar, a kind of paramagnetic behavior, but this one was anti-paramagnetic ones. So tetraphenyl phosphonium ion is some key factor for metal assembly.
Mikuriya-san, 2 minutes.
2 minutes. Yeah. Almost ending. We used the tetraethyl ammonium chloride in place of this one and obtain similar paramagnetic compound like this. Tetraethyl. So we sweep this compound to dimension 1 and for other tetrabutyl ammonium, we could obtain a single crystal, and we see chain compound and counter cation here. This one is loosely connected to routine unit. That's all. Thank you.
Thank you very much.
Thank you.